Hello friends, in this video we are going to study the comparison between the temperature transducers, resistant temperature detector which is known as RTD, thermocouple and thermistor. So let us start with our topic. If we talk about temperature transducer, then the names which come in our mind are resistance temperature detectors, that is RTD, thermistor and thermocouple. These are the most commonly used and most popular temperature transducers which are used for the measurement of temperature. So here we are going to study the comparison between these three temperature transducer. First, we will start with the working principle of these three transducers. As these three transducer, they are used for the measurement of temperature, but these three they uses different principles for the measurement of temperature. First of all, we will see the working principle of RTD. RTD, or we can say the resistance temperature detectors, they are the type of sensors which measure temperature by correlating the resistance of the RTD element with the temperature. Now, if we define resistance, resistance is the property of a material which opposes the flow of current, and current is the flow of electrons. Now, when the temperature of a element or of a conductor is increased, then the flow of electrons in that conductor also increases, due to which the current also increases. So as the temperature increases, the flow of electron increases, the flow of current increases. It means that the resistance decreases, because resistance always opposes the flow of current and they are inversely proportional. So if current is increasing, then resistance is decreasing. It shows that there is a relationship between the temperature and the resistance, that for some elements when the temperature is increased, their resistance increases, and there are some elements for which if the temperature increases, the resistance decreases. Okay, now depending upon it, there are two types of elements which are having positive temperature coefficient and negative temperature coefficient. So this relationship between the temperature and the resistance is used by the resistance temperature detectors, that is RTD, for the measurement of temperature. Okay, here we use the element which is having a positive temperature coefficient, means whose temperature increases, whose resistance increases as the temperature is increased. Okay, so that is the working principle of RTD. Now comes the working principle of thermistor. Now, thermistors, they are the contraction of the word thermal resistors. So, they are a type of resistors only, or we can say they are a special type of resistors in which the electrical resistance, it possesses either a negative or a positive temperature coefficient of resistance. As I have said that there are certain elements for which as the temperature increases, their resistance also increases, and those are known as the elements which are having positive temperature coefficient of resistance. Now, elements in which the resistance decreases with the increase in temperature, they are having negative temperature coefficient of resistance. So these thermistors, they are a type of resistors in which the element is having either a negative temperature coefficient of resistance or positive temperature coefficient of resistance. Okay, so when we can use them for the measurement of temperature by seeing their relationship with the change in the resistance. So in this way, the temperature is measured with the help of thermistors by having its relationship with the change in the resistance. Okay. Next comes the working principle of thermocouples. Now, in thermocouples, there is no relationship of the temperature with the resistance. Here, we are going to measure the temperature by measuring the output voltage. Okay. Now, what is a thermocouple? A thermocouple, it consists of two dissimilar metals. Two dissimilar metals, they are joined together to form the junctions. There are two junctions. One junction is called a cold junction, another is called the hot junction. Okay. Now, as the temperature on these two junctions is different, so due to that temperature difference, an EMF is produced at the two junctions. Okay, so the output voltage which is produced due to the difference in temperatures, or due to the difference in temperature at the junction, that is either cooled or either heated, that output voltage is related with the temperature difference. Okay, so here you can see that thermocouple is not using any relationship with the resistance. Here we are saying that when the temperature is changed, the EMF generated will be different. Okay, different amount of EMF will be generated at different temperatures. And if we see the working principle of RTD and thermistor, you have seen that they are relating the change in the resistance with the temperature. Okay. So that is the first point, or the first basis of comparison between the three temperature transducers. Second is the temperature range. Now, the range of temperature which can be measured with these three transducers is different. Means at different temperature ranges, different temperature transducer will be used. If we see the temperature range for RTD, it is minus 240 degrees Celsius to 649 degrees Celsius. If we see the temperature range for thermistor, it is minus 100 degrees Celsius to 500 degrees Celsius. If we see temperature range for thermocouple, it is minus 267 degrees Celsius to 2316 degrees Celsius. So if we see their temperature range, we can say that for the lower temperature ranges, we use thermistor. For the medium temperature ranges, we use RTD. And for higher temperature ranges, we use thermocouple. Okay. So that is the second basis of comparison between these transducers. Next is the type of transducer. These three transducers are the three RTD, thermistor and thermocouple are. Now, if we talk about the type of transducers, they are classified on the basis of different categories. One basis of categorization or classification is that whether the transducer is an active transducer or passive transducer. So, if we talk about RTD and thermistor, they are passive transducers, whereas the thermocouple, it is an active transducer. Because you have seen that the passive transducers are those transducers which require an auxiliary source for their operation, whereas the active transducer, they do not require any auxiliary source. The power which is required for their operation, it is produced by the transducer itself. Okay, so here we can say that RTD and thermistor, they are a type of passive transducers, whereas thermocouple, they are a type of active transducers. Okay, so passive transducer require an auxiliary source, so that the power which is required for the conversion of a non-electrical quantity into an electrical quantity, which is the function of a transducer, so that power will be given by the auxiliary source. Okay, whereas in the thermocouple, that is the active transducer which do not require any auxiliary source, this power which is required for conversion, it is provided by the quantity itself which is being measured. Okay, now here you have seen that in thermocouple, the electrical quantity generated was the output voltage. Okay, but here in RTD and thermistor, no electrical quantity is being generated, only the resistance, only the change in resistance is used to measure the temperature. Okay, so here do not require any auxiliary source. That is why they are also known as the self-generating transducers. So thermocouple, it is an active or self-generating transducer, whereas RTD, thermistor, they are passive transducers. Next is accuracy. If we talk about accuracy of RTD is, thermistor is somewhat good, but for thermocouple, it is very bad. Okay, so the RTD, they are going to give us the best accuracy, accurate measurements of temperature can be done. Thermistor, they will give somewhat accurate results, but thermocouples, they give inaccurate results. Their accuracy is very bad in comparison to RTD and thermistors. Next is linearity. If we talk about linearity, the RTD, they shows linear characteristics, means linear relationship is there between the resistance and the temperature. If we talk about thermistor, they give us non-linear characteristics, but the non-linearity is not so much. We can do linear approximation also for these non-linear characteristics. If we talk about thermocouple, they give us the worst non-linear characteristics, means highly non-linear characteristics or non-linear relationship is there between the temperature and the output voltage. Next is sensitivity. Among RTD, thermistor and thermocouple, thermistor are the highly sensitive temperature transducer. Thermistors, they give us the highly sensitive output because they are using the material which is having a negative temperature coefficient. So if we are doing any minute changes in the temperature, they are going to give us a high output for that changes. Okay, so because if we are changing the temperature for just say for 1 degree Celsius, the change in resistance will be so large that it can be easily measured. So we can say that thermistors, they are highly sensitive. After that comes RTD, and the least sensitive are the thermocouple. If we talk about cost, then thermocouple are the cheapest among these three and RTD are the highly expensive. So if we compare their cost, then we can say that RTD is the expensive one and thermocouple is the cheapest. Next basis of comparison is the interchangeability. Interchangeability means that if the RTD or if any of the temperature transducer is damaged, then the replacement of that transducer, is it easy or not? So if we talk about the interchangeability of RTD, it is excellent. For thermistor, it is fair, and for thermocouple, it is poor. Okay, so if if an RTD it has to be interchanged, then it can be easily done, but interchanging in the case of thermocouple, it is very bad. Next is repeatability. Repeatability, it is the measure of how close the frequent measurements done on an instrument, they are close to each other. Like we are using the same transducer for the measurement of temperature. Again and again for the same measurement, we are using that instrument. So how close the output results of those measurements, they are from each other, that is called repeatability. That how the instrument is repeating its output. Okay, so in case of RTD, it is excellent. In case of thermistor, it is fair. And in case of thermocouple, it is poor. Okay. So repeatability means the output results, they are going to repeat itself in case of RTD, but in thermocouple, the closeness between the results will be less, so it is going to give us poor repeatability. Next comparison is the manufacturing material which is used for the construction of these temperature transducers. The resistance temperature detectors, that is RTD, they are made up of the materials which are having the positive temperature coefficient. So the element which is mainly used for the construction of RTD is platinum. So the manufacturing material for the RTD are the films or coils of metals such as platinum, and all those metals which are having the positive temperature coefficient of resistance, they can also be used for the construction of RTD. Then comes thermistor. Now for thermistors, the materials which are having negative temperature coefficient of resistance or positive temperature coefficient of resistance, both can be used, but mainly we use the materials which are having negative temperature coefficient. So for thermistors, we use negative temperature coefficient of resistance materials like the semiconductors. So ceramic materials, semiconductors like cobalt, manganese or nickel oxides coated in glass, they can be used for the construction of thermistors. Next is thermocouple. Now in thermocouple, we have seen that thermocouple, it consists of two dissimilar metals which are joined together to form the junctions. So here we can use any of the metals for its construction. So for thermocouple, any two dissimilar materials can be used like iron constantan, nicrosyl nickel or nickel constantan. So any combination of two dissimilar materials can be used. Now next basis of comparison is the applications of these temperature transducers. If we see the applications of RTD, they are used in air conditioning, so air conditioning, plastic processing, microelectronics, exhaust gas temperature measurement, for these applications RTD can be used. If we see the applications of thermistor, So applications of thermistors are potential divider networks, temperature compensation, circuit protection, and volume control. Because thermistors, they are highly sensitive, so if there is any change in temperature, it can be easily measured by it. So they are highly used in the circuit protection networks where they are used in combination with the relays. Okay. Now, if we see the applications of thermocouple, now as we have seen that thermocouple, it is mostly used for the higher temperature ranges. So wherever we are having the high temperature values, we will use thermocouples. So thermocouples are mainly used for the kiln temperature measurements in the plants, for rocket engines, for machines, etc. So for higher temperature measurement applications, thermocouples are used. So in this video, we studied the comparison between the three temperature transducers, resistant temperature detectors or RTD, thermistor and the thermocouples. We consider various points, and on the basis of that points, we see the difference or the comparison between the three transducers. So I hope that this topic is now clear to you. Thank you.